This is Bob Capetta from the College of the Florida Keys, and this lesson is on completing the square. So let's start with the following question. If I have x squared equals 9, the strategy we've studied so far is to solve these sorts of problems with factoring. So to do that, we must have one side equal to 0. So if I subtract 9 from both sides, I get x squared minus 9 equals 0. And then we need to factor x squared minus 9. So let's plug this into our factor box. X squared minus 9, x squared here, minus 9 here with 0 or 0x in the middle. X times x is x squared, minus 3 times plus 3 is negative 9. We have negative 3x and positive 3x, so my answer is x minus 3x plus 3 to factor this. So I get x minus 3 times x plus 3 equals 0, which means x minus 3 is 0 or x plus 3 is 0. If x minus 3 is 0, x is 3. If x plus 3 is 0, x is negative 3. So our answer to this question is the set of values 3 and negative 3. What I want to point out, this is quadratic, highest power is 2, and we have two solutions. So I want you to keep that in mind. If there is a quadratic equation, we typically have two solutions. But that's the method we've already learned. So let's take a look at an alternate strategy. If I have x squared equals 9, what can I do? We can take the square root of both sides, but we have to be careful here. The square root of x squared is actually the absolute value of x, and the square root of 9 is 3, which gives me x is plus or minus 3. So in that circumstance, when I take the square root of both sides, I need to make sure I remember the plus or minus. And the thing to recall is that if you have a quadratic, if the highest power is 2, then you should have two solutions. So my answer here, x equals 3 or x equals negative 3, is what we get for our solution. Now we can make this a little bit harder, and we can look at something like this. If I have x minus 2 squared is 12, I could multiply it all out. I could subtract 12 from both sides. I could try to factor, which it probably won't factor, frankly, and then I'll have some difficulty. But what I'm going to do instead here is I'm going to take the square root of both sides. So we'll take the square root of x minus 2 squared should equal the square root of 12. The left-hand side is actually the absolute value of x minus 2. The right-hand side is the square root of 12, which we should simplify. 12 is 4 times 3, or 2 times 2 times 3. Pair of 2's, and we get 2 root 3. So I get the absolute value of x minus 2 is 2 root 3, or just remember, x minus 2 is plus or minus 2 root 3. Again, two answers for a quadratic equation. If the highest power is 2, we typically have two answers. Adding 2 to both sides, we will get x is 2 plus or minus 2 root 3. So two answers there. We could have x is 2 plus root 3. We could have x is 2 minus root 3. So our answers will be 2 plus root 3, comma, 2 minus root 3. Now notice that has irrational solutions. We cannot get those if we are starting with our factoring strategy. So a technique like completing the square will be necessary if we want to get irrational solutions. Same thing goes for complex solutions. If I have a question like this, like 3x minus 1 squared equals negative 16, we're going to go ahead and take the square root of both sides. Square root 3x minus 1 squared is square root of negative 16. The left-hand side is actually absolute value of 3x minus 1. The right-hand side is the square root of negative 1 times the square root of 16. So in a sense, we get absolute value of 3x minus 1 is I times 4. So absolute value of 3x minus 1 is 4i, which would tell me 3x minus 1 is plus or minus 4i. Adding 1 to both sides, we get 3x is 1 plus or minus 4i. And then we'll divide both sides by 3. Divide by 3, divide by 3, and we get x is 1/3 plus or minus 4i over 3, which we should write our answer two ways. So x is 1/3 plus 4i over 3, or x is 1/3 minus 4i over 3. So our answer is those two solutions. Again, a quadratic equation typically has two solutions. So 1/3 plus 4/3 I make it look a little bit more like standard form, and 1/3 minus 4/3 I. Real part 1/3, imaginary part 4/3. But we don't always start with problems in this form, so we need to work to get there. So let's take a look at the process. So we're going to look at a quadratic equation in more standard form, in more typical form. X squared minus 4x plus 3 is 0. Let me go ahead and solve this by factoring first, and then I'll solve it with completing the square strategy. So if I solve it with factoring, what do we get? Have x squared here, have 3 here, minus 4x here, x times x. Negative 3 times negative 1, negative 3 times x is negative 3x, negative 1 times x is negative 1x. So we get x minus 3 times x minus 1. So we have x minus 3 times x minus 1 is 0, which means x minus 3 is 0 or x minus 1 is 0. So adding these, the 3 to the other side, the 1 to the other side, I get x is 3 or x is 1. So my answer is 3 and 1. So that is the factoring strategy, but that's not the only way we can solve this. So what we're going to do is we are going to add the 3 to the right side, and we're going to rewrite this as x squared minus 4x equals negative 3. And I want to add something to both sides to complete the square. Now we know we should get an answer of 3 and 1. That'll be a way for ourselves to check. So how do we complete the square on x squared minus 4x? Again, multiplication box this time. X squared in the lower corner. Negative 4x, I get negative 2x and negative 2x. So I need these two slots to add up to negative 4x. So how do I use up negative 4x in these two slots equally? And the answer, of course, is take half of negative 4x or negative 2x. Now how do I complete the square? Well, this is x times x. To get x squared, x times what is negative 2x? Negative 2, negative 2. So how much do I have to add in that fourth slot to complete the square? Well, I have negative 2 times negative 2, which is positive 4. So positive 4 completes the square. I add positive 4 on this side, and I add positive 4 on that side. Because what I've shown with this multiplication box is x squared minus 4x plus 4 equals x minus 2 times x minus 2. Or if you like, x squared minus 4x plus 4 equals x minus 2 squared. So the left-hand side here is x minus 2 squared. The right-hand side is negative 3 plus 4, which is 1. Now I can go ahead and take the square root of both sides, but be careful when you do that. We're going to need a plus or minus. We're going to need an absolute value, something like that. Square root of x minus 2 squared is square root of 1. So the absolute value of x minus 2 is 1. So x minus 2 is plus or minus 1. So that means x is 2 plus or minus 1. So I get x is 2 plus 1, or x is 2 minus 1. So we get x is 3 or x is 1. Which makes me happy because that's what we obtained earlier when we solved it with factoring. So again, a quadratic equation, it has the highest power of 2, typically has 2 answers. They are, in this case, 3 and 1. Okay, let us take a look at another one of these. So we'll look at x squared minus 6x minus 7 is 0. I want to quickly solve it with factoring because I can. But recognize most of the time you cannot solve it with factoring. So I have x squared here, I have negative 7 here, I have negative 6x here. X times x, negative 7 times positive 1. Negative 7x, positive 1x, x minus 7 times x plus 1. So x minus 7 times x plus 1 equals 0. X minus 7 is 0. Or x plus 1 is 0, so we get x is 7, or x is negative 1. But again, completing the square can solve problems that can't be factored, which you'll see in our next example. But we want to go ahead and solve this with completing the square. So we're going to add the 7 to the other side, so it will be x squared minus 6x equals 7, and it's going to be our job to complete the square. What do we add to both sides so that the left-hand side is a perfect square? That's what we need to ask ourselves. So x squared minus 6x. X squared goes here. These two slots add up to minus 6x. So let's go with minus 3x and minus 3x. We need to figure out what goes in this fourth slot to complete the square. So x times x is x squared. Negative 3 times x is negative 3x. Negative 3 times x is negative 3x. But negative 3 times negative 3 is positive 9. So positive 9 will complete the square. Add 9 to both sides. And what we see over here, we see that this factoring box tells me that x squared minus 6x plus 9 equals x minus 3 times x minus 3, or x squared minus 6x plus 9 equals x minus 3 squared. So on the left-hand side of this, I have x minus 3 squared equals 7 plus 9, which is 16. Our next strategy is going to be to take the square root of both sides. Square root of x minus 3 squared is the square root of 16. So the absolute value of x minus 3 equals 4. So x minus 3 is plus or minus 4. Add 3 to both sides. X is 3 plus or minus 4. So I get x is 3 plus 4, x is 3 minus 4. So x is 7 or x is negative 1. Which makes me happy. That's what we had up here as well. So we write our solution set in this form. Well, the two examples we did both could have been done with factoring. But let's go ahead and do one now that couldn't have been done with factoring. And we'll show you how that process works. So if I have something like this, x squared plus 8x plus 4 equals 0, which does not factor. So factoring is not a strategy that we can use. We need to add the 4 to the other side. X squared plus 8x equals negative 4. We recognize it is a quadratic, therefore we should have two solutions. We need to create a square to complete. So let's do that. I have x squared plus 8x. 8x split into these two boxes. Both should be plus 4x. So x times x is x squared. X times plus 4 is plus 4x. X times plus 4 is plus 4x. So to complete the square, plus 4 times plus 4 is plus 16. So then what we have is we have x squared plus 8x plus 16 equals x plus 4 times x plus 4, or x plus 4 squared. So adding 16 to both sides, that's what completes the square. Add 16 here, add 16 here. So what I have on the left-hand side is now x plus 4 quantity squared equals 16 minus 4, which is 12. Then we'll take the square root of both sides. Square root of x plus 4 squared is the square root of 12. So the absolute value of x plus 4 is the square root of 12, which is what? Square root of 12 is square root of 2 times 2 times 3. That's 2 root 3. So absolute x plus 4 is 2 root 3. So x plus 4 is plus or minus 2 root 3. Add negative 4 to both sides and we get x is negative 4 plus or minus 2 root 3. So again, we have two answers. What are they? X is negative 4 plus 2 root 3. And x is negative 4 minus 2 root 3. Negative 4 plus 2 root 3. Negative 4 minus 2 root 3. So that's one that could be solved with completing the square, but could not be solved using the factoring technique. All right, let's go ahead and do one more, but we're going to add another wrinkle to it. Let's do the following. X squared minus 5x plus 1 equals 0. Again, it doesn't factor. So if we're going to go ahead and use completing the square, we've got to have the number on the other side. Add negative 1 to both sides. X squared minus 5x equals negative 1. And we want to complete the square here. How are we going to do it? This way. X squared here. These two slots add up to negative 5 halves. Add up to negative 5x. So cutting it in half, they're each negative 5 halves x. Negative 2.5x, negative 2.5x, and negative 2.5x gives me negative 5x. So if that number is odd, we are forced to deal with fractions. So negative 2.5x, which is negative 5 halves x, negative 5 halves x here. So yes, odd numbers make this more challenging. X and x here. X times negative 5 halves gives me negative 5 halves x. X times negative 5 halves gives me negative 5 halves x. Multiply those together. Negative 5 halves times negative 5 halves is positive 25 fourths. That is what will complete the square. So we add 25 fourths to both sides. So what we have here is this box, whole thing, x squared minus 5x plus 25 fourths is x minus 5 halves times x minus 5 halves, or x minus 5 halves squared. So the left side here is x minus 5 halves squared. The right-hand side is -1, -4/4 plus 25/4, which would be 21/4. So let's go ahead and take the square root of both sides. Square root of x minus 5/2 squared is the square root of 21/4. So the absolute value of x minus 5/2 is square root of 21/4, which is root 21 over root 4, which is just 2. So I get x minus 5/2 is plus or minus root 21 over 2. So x is 5/2 plus or minus root 21 over 2. So I have two answers. What are those two answers? X is 5/2 plus root 21 over 2, or x is 5/2 minus root 21 over 2. So our answer is, in the curly braces, 5/2 plus root 21 over 2 and 5/2 minus root 21 over 2. And that will conclude this lesson.